In this session, let's start looking at how we actually perform conjoint analysis in SPSS. First of all, what is this conjoint analysis? This is one of the tools used extensively in market research, especially for effectively designing a product. See, sometimes probably I collect a survey from some of the customers asking them to rate some of the features of the product. So just trying to find out which attributes of the product are important and which attributes of the product are least important to the customer, or from a customer's standpoint, what are which features are desirable versus which features are least desirable. This kind of analysis can very well be understood by conjoint analysis. So for that purpose, we will look at, let's say, a mobile features. Let's say a company is interested in launching one mobile product. So for that, it is more interested in trying to find out the various features associated with the product. And from that standpoint, let's say it is looking at introducing some of the features. So it wants to conduct a survey from the various participants on what is their opinion on the various features of the product. Which features would they be desiring more versus which they would be desiring less. If I give them one by one, the most common scenario is they would like to prefer very extraordinary features, probably at a lesser price, but it may not be feasible for the company. So that is what the conjoint analysis is trying to address. Now all combinations, let's say I have I'm thinking of three different varieties, three different ranges of price, and I'm thinking of three different features, or let's say the operating system, three different operating systems I am planning out, or I'm planning out 3G support versus non 3G support. So like that, if I have a few types of variants, how well different customers rate each of these variants is what we are trying to do as a part of the conjoint analysis. So for that for that requirement, I am just listing out, let's say a customer is interested in some of the mobile manufacturing company is interested, let's say, in some of understanding the customers responses about the following features. One, I am looking at the operating system support. Should I go for Android? Should I go for Windows? And should I look at Symbian? Let's say three operating systems are there in mind. Or let's say 3G support, yes or no. These are the two features which the company wants to evaluate. Then I would also try to look at price. Let's say less than 10,000, 10,000 to 20,000, and 20,000 to 30,000. These are the three price ranges which the company is looking at. Then camera features. The company is thinking of less than 3 megapixel as one, 3 to 8 megapixel cameras, and greater than 8 megapixel. Let's say three categories even in terms of camera. And so we can think of any such kind of features associated with the product. Now with these kind of features associated with the product, the company is really looking at how different customers visualize each of these features. So if I try to give them a choice, they'll always say, I would like to have a 3G feature camera, a 3G feature phone with greater than 8 megapixels camera, but at less than 10,000. If I give each of them independently and ask them to rate their preferences, it goes more or less in this way. So from that standpoint, I would like to administer the survey in such a way. In reality, if I find out the number of permutations and combinations that could be created with these set of features, I can very well say that the number of combinations that can be created is 3 of this, multiplied by 2 of the second one, multiplied by the 3 of the price, and multiplied by 3 of camera. It will result in 54 different permutations and combinations. And probably if I keep adding some more features, probably another important feature, probably let me add something more, display. Someone wants only QWERTY keyboard. Someone is looking at non-QWERTY keyboard or touch, or even touch as well as QWERTY. So something like this. So if I keep adding a number of features, now in this case the permutations will even be multiplied by 4, making it 216. Now if I give all these 216 features for the customers to rate, which one is the highly desiring kind of a feature? Probably they all would prefer this combination. A Windows operating system with a 3G feature, less than 10,000 bucks, greater than 8 megapixel, along with touch and QWERTY. Probably, but when you are launching the product, it may really be not feasible. So we are trying to understand the rankings of the customers relating to the various products, and based on that you would like to take a decision on what is the most preferred product from the mindset of the customers. So for that purpose we are actually getting into a conjoint analysis. Now generating these 216 different outcomes and extracting the responses or asking the customers to rate these 216 would be a literally difficult task. And for that purpose, the SPSS supports a concept called orthogonal design. What this means is, out of these 216, on a random basis, the system will identify some number of cases in such a way that a good representation is there across all the features. So all features are all the different OS, all the different 3G combinations, price combinations, camera combinations, display combinations. A good set of them are used across the across the different combinations, and the number is not 216, probably much lesser, somewhere around 25 or 30 combinations, which will help the system analyze all the 216 in a much better way. That is what is called as orthogonal design. And how we do that orthogonal design, once we do the orthogonal design, generating let's say around 20 or 30 kind of different combinations, we can ask the customers to rate these 30 combinations rather than giving them 216 combinations to rate. That makes even the customers give their preference in terms of their choice, and that will help the companies to assess well in terms of which product is, or which feature of the product is highly desirable by the customers versus which one is least desirable. So from that standpoint, I am initiating the process of generating an orthogonal design. So what we do is, in SPSS, we go into data, orthogonal design, and I say generate. I want to generate this orthogonal design. So it asks for the different factor names. Factor names are different features which we talk about the product. So the first one I say OS, and here as a factor label I'll call it as operating systems. Oh, something is happening. Let me call it as operating system. I add, and for this I'll define the values. Probably I say 1 means, I will say 1 means, I'll get it from the Excel sheet, Android, 2 means Windows, 3 means Symbian. 1 means Android, 2 means Windows, 3 means Symbian. Alright. So this is about the operating system. Then I am looking at 3G. So I'll define a variable called G3, as I cannot define it as a starting with a number. So I am defining it as G3, and in the description I am calling it as 3G feature. Yeah. Now adding the 3G feature, I am even defining 1 means no and 2 means yes. All right. Then I am adding a third feature where price or probably camera. So I am pulling in camera megapixels. So I am adding 1. Here I am defining 1 means less than 3 megapixel, 2 means 3 to 8 megapixel, and 3 means greater than 8 megapixel. So this is one more thing I am adding. Then I am also adding display, wherein the display type. So for that I am adding one more, and here I am defining it as 1 means no QWERTY, then 2 means QWERTY, 3 means touch, and 4 means touch as well as QWERTY. Alright, so this is one more set of features I am adding, and probably the final one I am adding as price, the price of the mobile. So these are the 5 features or attributes which I would like to understand which one the customer is giving more importance to. So I am saying less than 5,000. I am also putting 5,000 to 10,000. Then the 3 putting it as 10,000 to 25,000, and probably 4 putting it as greater than 25,000. So these are the 5 features I am seeing that the customer would be evaluating. So for that I am giving these kind of combination. Now if I try to develop the full set of permutations and combinations, this number is going to be very high, and it becomes pretty difficult for the customer to rank the preferences. So from that standpoint, what we are saying is I'll create a new dataset file from where the orthogonal design, some set of numbers would be generated. Probably 20, 25, 30 would be generated as a data set which will contain 30 different kinds of plans which the customer would be ranking on. So for that I'll create a data set with the name mobile combinations. This is the data set I'm talking about. And so we are looking at some random number to be generated. So based on some random number, so I'm giving, let's say, 20 lakhs, some number based on which this entire generation has to happen. All right, so I'm even saying minimum number of cases to generate. Okay, let's go with 30 cases out of that 216 or whatever combination that could be generated. I want only 30 to be generated so that the customer can rank them much easily. And at the same time, there is a mention about number of holdout cases. Holdout cases are those cases which would be generated, which would be given to the customers to rate, but they would not be used for the purpose of model generation. So the customer will rank those kind of products also, will rank that kind of features also, but they would not be used for generation of the model. Instead, they would be used to verify the model that has been generated. So we'll say number of holdout cases probably around 5 or something, right? 5 or 6 holdout cases which are used for testing purpose, not for generation of the model. And I'll say randomly mix it with the other cases so that the customers or subjects don't know which ones are holdout and which ones are really used for building of the model. All right, let's say continue. And when I do OK, what we'll observe is we get a data set with 32 cards. The total plan is generated with 32 cards, which means 32 data elements, wherein 26, though we asked for 30 to be generated, the system has identified 26 is the minimum number that needs to be generated. So it has given 26 different combinations. So now you see there is a neat spreading across Windows, Symbian as well as Android. There is some spread about the yes and no feature. 3 less than 3 megapixel, 3 to 8 megapixel, all combinations are existing. Even the display, different combinations are existing for display, and the price range also. So that's how the system has generated a total of 38 cases, out of which 6 are holdout and the remaining 32 are for design. So that's what you are seeing. These are design cases, which means they will be used for as a part of our model, whereas the holdout ones are primarily used for the testing purpose. But the customer now has to rank all these 38 cases as to which one would be their highly preferred kind of combination, which will help the company to really evaluate what would be the preferences of the customer as far as these 5 features of a cell phone are concerned. Now what we are seeing is the 5 features which we have displayed, they come as a part of 5 variables. Apart from that, 2 new variables got introduced in our orthogonal design. One is a card number, which is nothing but the identifier, and the other one is called status, which will tell you whether the record or whether the set of features are used for designing our model or are they used for the testing purpose. So this is the first step as a part of our conjoint analysis. Out of the 216 or whatever combinations that are possible, I am trying to reduce them to a comfortable set so that the customer can rank them more comfortably. And instead of me trying out on a random basis, we have given one number to start as a random number. So on a random basis, I am asking the system to generate some number of cases. Though I said 30, the system is able to identify that 32 is the minimum number that is required to generate these cases. So it has generated 32 cases plus 6 holdout cases. So now these 38 will be given to different customers for rating the system, right? So I have already generated, I have already given this analysis to different customers to typically rate these 38 subjects, 38 preferences. Which one would they rank as the first preference? Which of these 38 items they would rank as the top preference, and which one they would rank the last preference, kind of stuff. So based on that, our conjoint analysis will identify which variables or which features are being stressed upon a lot by the customer, and which of them are not stressed that much by the customers. All right. So let's now start looking at the solutions which were filled by the various customers, because this entire 38 features are circulated to almost 25 to 30 customers, and ask them to fill their preferences across the various all this 38 products. So based on taking those 38 products, let's try to evaluate how this conjoint analysis helps us in rating or in trying to understand the importance of each of the variables, so that we can very well get into an effective product design. Yeah, this is the sheet where we have captured the responses of various customers. So this we have this talking about 38 preferences, and what this customer one thinks as his first preference. So customer one says item number 4 is his first preference. So which means he would prefer an Android phone without a 3G connection, but greater than 8 megapixel camera and a QWERTY keyboard for less than 5,000 bucks. That is his highest preference, which is probably which may or may not be feasible for the company, but that is what the first customer is preferring. But when we look at, let's say, the sixth customer, he is preferring the item number 32, Android phone with a 3G megapixel 3G connection, greater than 8 megapixel, touch screen, in the range of 10 to 25,000. Now whether it is really feasible or not, the company will be evaluating that scenario. So now these are the kind of preferences of 27 customers we have captured. Now this 27 preferences, let's take them into SPSS, right? Even this data mobile combinations will take one more new file where we would capture these 27 preferences. So this conjoint analysis actually works with two files, one containing the master of the various combinations, as we have seen in this file called mobile combinations, and we'll have one more data file which primarily focuses on the preferences of the various customers. So since we have captured that in Excel, I'll try to open that file. So I'll say read text data. Where did I save it? I'll go with Excel. Alright, Excel files, and the file is named customer preferences. Yeah, customer preferences.xls. So this is what I am trying to import. Right, sheet 1. No, I'll go with sheet 2. A1 to AM28, and I'm saying read the variable names from the first row of the data. Okay, I'm saying okay, which would be pulled into a new sheet. So I'm talking about an ID which talks about 27 customers and their preferences, their ranking for all the 38 preferences that are existing. So this one I would like to save it in the, probably let me maintain a simple location D. To make it more simple, I'll make it as D. In D, I'm putting it as customer underscore responses dot sav. Even this mobile preferences, let me do the same thing. I'll do the save as. Let me do the same in D. I'll call it as mobile combinations dot sav. So that while doing the coding, it becomes easier in trying to set the path. So now that these two files are ready for us, one is the master data file which contains the various features and an orthogonal design being generated out of these features. So which generated 38 different combinations for us, and after asking the customers to rank these 38 combinations, this is the way we have captured the results of all the 38 combinations from 27 customers. This is when we start off with the generation of the code for conjoint analysis. Using these two files together, we would start off with the conjoint analysis, and as a part of generation of the code for conjoint analysis, let's start off where I open the script. I create a new small script has to be written for this purpose. So I'll say open file new, I say script. So in the script, I'll maintain a new script which I call as conjoint. I write a new script called conjoint, where first thing I have to define is the name of the plan. The plan in our case is the file which contains the master. So I'll simply say D colon mobile combinations dot sav. That is the name of my plan. The name of the plan is mobile combinations dot sav. Then at the same time I have to define where the data is. So for that I say slash data, which is the file that contains the responses. So I say D colon, where are those responses? Customer preferences. So I say customer underscore preferences dot sav. So this is one more aspect to look at. Now in this data, where are our sequences? So that's what I define as a slash sequence. What are our preferences? Which are the locations or which are the variables that contain our preferences? So I say pref1 to pref38. These are the variables. So I give the variables as pref1 to pref38. That will contain, those are the ones which are rated by the customers, which are nothing but, if you look at our Excel sheet, pref1 to pref38 remain as those variables where the rankings are present. And what is the name of the field that talks about the subject or the customer? We have actually given the field name as ID, where we captured the names of the customers. So that's one more thing we have to give. And along with that, I will also give the preferences on the various factors. Now, whatever the factors I have defined, let's say the factors which we have defined in mobile combinations, one is the OS. So let's write OS. I write OS, and in the bracket I call it as discrete, because there is no reason, or there is no increasing or decreasing relationship in the OS. Like Symbian, Android, and Windows. There is no increasing priority or decreasing priority. We have given 1, 2, 3 for Symbian, Windows, and Android in just that random order. There is no, literally, there is no relationship between 1, 2, 3. I cannot say Windows is bigger than Symbian, or Android is bigger than Windows. No such kind of greater than relation or less than relation can be observed. So that's where I call it as discrete. Now, what are our other features? Then we have G3 as a feature. Yeah, G3, we defined 1 means no, 2 means yes. So it's probably like a increasing order. So, 1 is more preferred compared to less. So something like that. 2 is more preferred compared to 1, which means 3G yes is more preferred compared to 3G no. So there is a kind of an increasing trend in the G3 variable. So that's where I call it as linear more. This is the name which we give for G3, because there is a kind of increasing relation. Wherever there is a decreasing relation, we can write it as linear less. Now when we look at the third one, camera, even this one I can call it with a linear more, because when I have given less than 3 megapixel, then 3 to 8 and greater than 8. So this goes with a linear more. Similarly, the fourth parameter which we have given is display. Even the display can be looked at as linear more, because no QWERTY as the first one, then QWERTY only, then we are talking about only touch, then touch plus. So it's like an increasing order. So that's where I am calling it as linear more. Whereas the last parameter, price, I call it as linear less. The reason being, the high price generally will be less preferred compared to the low price. The reason why we give these things is the system will be more comfortable in trying to analyze the data for us if we give these kind of factors. So these are some of the important things that needs to be given as a part of our code to run our conjoint analysis. All right, let's now try to run this conjoint analysis. Let's see whether the output is coming out the way we expect. I say start. Okay, let's look at what is the output that is coming out. Yeah, this has to be written, this entire piece of code has to be written as a part of syntax, not in script. So you should open, let's say this was what we have written earlier. So what you need to do is, not in syntax, you open new script, new syntax, not script. In this new syntax, you write this conjoint, plan, data, sequence, subject, factors, all these things. Now then try to simply run this. when you are running it, let's check out what has happened. There is a message that is occurred. The D customer preferences.sav, the file does not exist. Oh, it's not customer preferences. We had customer responses.sav. Alright, so let's change the word here. Instead of customer preferences, let's call it as customer responses.sav. Now again, let's run this entire stuff. Alright, conjoint plan. Yeah, now we are getting the output. So we are getting some kind of an output where our code sequences, subject, factors, all these things are displayed. Along with that, some more details are described, like model description, which is saying OS. There are three different types of OS we have given, and the relation we have mentioned is discrete, which means there is no relationship in the increasing or decreasing order with respect to those three. Then with respect to 3G, again there are two levels, yes and no. Camera, there are three levels. Display and price, there are four levels. And all these are created in an orthogonal way. This is what the initial analysis is coming out. Then we are also seeing, okay, subject 1, customer 1, all these kind of data is coming out, right? We are getting for each of the subject what is the total preference. And yeah, here the part is the output. If we are asking it to display in full almost the entire, for every customer, what is his preference, all that stuff is coming out. Now how do we interpret this output? We'll come to this part. But a small modification that you can also think of doing is, instead of printing this entire output customer by customer, what you can say is you can simply say print. So these are the various things you can ask. So I'll say print equal to, I'll say summary only. Only summary, do the printing. So that it will do the printing of only the summary, not the entire stuff. So this is, so instead of giving the idea of each and every subject, each and every customer, here it gives it as a summary. So this is more sufficient for us to evaluate which features are of more importance and which features are less importance to the various customers. So let's look at trying to understand the entire output that has been generated by the system, which will give us more and more comfort level in our analysis. Now, interpreting this output, first thing I would look at is the overall statistics. There is a mention of, for each of the features that we have displayed, there is a mention about the utility estimate. The higher is the utility estimate, what we can very well say is the customer is preferring this more and more. And if there is a very big negative, then it is saying that the customer is more choosy about it. Now if I see relationship between price and utility, it is showing a negative relation, which means the higher is the price, the lesser is the utility. But what we are observing is there is not much of a difference. 15, 0.15, 0.3, 0.46, 0.61. So but still what we are observing is the higher is the price, the lesser is the utility in case of the price. Similarly, when we are looking at the display, the higher is the features. So touch plus QWERTY is being preferred, given more and more utility compared to a no QWERTY, right? And similarly, camera wise also, the higher is the number of megapixel, it is showing a kind of a decreasing relationship. And with respect to 3G, the higher the better it is. Whereas in case of OS, Windows is being looked at as most preferred one, whereas the Symbian is looking at being the least preferred kind of an operating system. Now, if I have to look at the utility for each of the preferences, now I can very well compute the utility for each of the scenarios by applying this kind of formula. For example, let's say I would like to find out the utility for item number 1, for the preference number 1, Windows. Yeah, Windows is 0.713. So let me put it into a spreadsheet. Windows is having 0.713. Right, let's try to put it as a formula. 0.713 plus G3. G3 is S. G3 is S is having 2.556. So 2.556 plus, then the next feature for scenario 1 is less than 3 megapixel touch plus QWERTY. Less than 3 megapixel is minus 0.032. So I'll say minus 0.032 plus touch plus QWERTY is 1.252. 1.252 plus, what about the fifth one? The fifth one is showing price is 5,000 to 10,000. 5,000 to 10,000 is minus 0.307. So I say minus 0.307 plus a constant which was 14.209. 14.209. So the utility for the, in case of the first preference, is 18.391. Now the same way I can try to compare the utilities for all of them. The higher is the utility factor, the higher it is preferred by the customers. That combination is more preferred by the customers compared to the other ones. So from that standpoint, I can look at the similar kind of calculation for all of them, and finally choose that kind of a combination which is more feasible. Because one thing which I can understand here is, when I look at the importance which is expressed in terms of percentage, what we are observing is OS as well as price. Price is looking as the highest value, 23 almost. So price is a very key factor. Then comes the OS, then the camera, then the display, but finally the 3G. So whether it is 3G enabled or not is becoming one of the least preferred things out of these 5 preferences for the customer. As based on whatever the customers whom we have surveyed, it is looking like the price becomes the most important factor, whereas the OS is the next, whereas the 3G factor looks the on the lower side. And now if I look at the correlations, what it is saying is 0.51 between the observed and the estimated preferences. What we are observing is the correlation between the observed and the estimated is only 0.51, which is also a cause of concern, because in some cases probably people might have answered these things in a random fashion, and that's the reason we are getting all kinds of combinations which has resulted in a very less correlation. But generally if I get around 0.8, 0.9, it becomes very much authenticated for me to take these are the preferences which are very much preferred by the customer. These are the attributes which are more looked upon by the customers. These are the attributes which carry a less importance in the minds of the customers, something like that. So, and when I look at this correlation with respect to the holdouts, it's looking even more pathetic, more in the negative terms. Whereas when we look at for the design ones, it is looking positive. So there is some kind of an issue that the ones which we are used for designing the model, if I'm trying to apply the same model on the holdout preferences, the results are slightly more embarrassing, which can very well be observed even in terms of number of reversals. Reversal is an opposite behavior. As we have defined, in case of camera, the higher the better is 3 megapixel, 3 to 8 megapixel, greater than 8 megapixel. So the higher it is, the better it is. Whereas when it comes to the factors, what has been observed is in case of 13, when it comes to camera, 13 have been shown a reversal factor, which means customers in they have preferred a 3 megapixel or less than 3 megapixel camera more compared to a greater than 8 megapixel camera, which means so 13 such customers have shown a reversal trend in terms of the feature as far as camera is concerned. 12 as far as price is concerned, as we have mentioned that with respect to the price, probably less than 5,000 should be highly preferred, and then greater than 20,000 or 30,000 needs to be preferred. But whereas the customers have shown a slightly reversal kind of a behavior. When it comes to 3G also, 9 of them have shown a reversal behavior. And when it comes to the subjects, so customer 1 has shown reversal in case of 2 in 2 cases for 2 of the factors. Customer 2 has shown reversal for 2 of the factors, and so on. What we are observing is a lot of customers are showing some kind of reversal at least in 1 or 2 or 3 factors, except for customer 7 who has not shown reversal on any case. Customer 10, only 2 or 3 customers are there who did not show any kind of reversal. So which means there could be some problem in the way the customers have filled this response, because they are showing all kinds of reversals, which means the numbers 1 to 38 might have been assigned in a random fashion also. But assuming they have filled it properly, this is what is the analysis that the mobile company can look at. It could very well see, even if I go back customer wise, what we are seeing is customer wise, what is his preference. Yeah, if I look at now customer wise summary, customer 27, for him heavy importance is on price, whereas he is least bothered about the camera. That is how customer 27 has looked at. But whereas customer 26, he is giving more or less equal importance to price as well as operating system, but yeah, least importance again to a camera. Customer 25, very high importance to 3G as well as the price, but very less importance to operating system. So different customers have given different kinds of priorities and preferences as far as these various features are concerned. Overall, if I have to evaluate, this is the kind of output that is going to generate. And finally, what we are saying is, as far as if I take this survey to be realistically filled by various customers, what I am observing is the OS as well as price form a very critical factors, whereas 3G forms a less critical kind of a factor. But what is also observed is the correlation is slightly poorer, along with the number of reversals. Number of reversals are almost 50% in almost all the cases, which makes it slightly difficult to accept the study. But if this entire analysis has been done very much appropriately, what we could correlate is which features are strikingly important for the various customers versus which features are relatively unimportant. This conjoint analysis is used very heavily in the market research in terms of finding out the attributes of the product and defining the features of the product in a more effective manner. Is this clear to everyone? You can take different kinds of data sets and you can do the practice on this. If you have any further queries, please get back to me on this.